In this lesson, we're going to learn how to work with exponents in expressions that involve raising powers to powers. Let's see what that means. Here we have an expression, x to the second power raised to the fifth power. We basically have the parenthesis raised to the fifth power, which means we are multiplying what's in the parenthesis by itself a total of 5 times. We learned previously that when we multiply like bases, we add their exponents together. So we add these exponents together to have a total of 10, x to the 10th power. Now it's not really necessary to write out the extended product to evaluate these. There's a shortcut we can take. Notice the 2 exponents on the original problem, and notice the exponent on our answer. If we take those 2 exponents in the original, 2 and 5, and we multiply them together, we get 10, which is the exponent on our answer. So we can use a little bit of a shortcut. When we have a power raised to a power, all we have to do is multiply those exponents together, and that will give us our answer. It's as simple as that. A general rule: if we have x to the a to the b power, we get x to the a times b. And similarly, if we have different bases, we simply multiply the exponent for each base by the exponent on the outside of the parenthesis. In English, we would say, when raising a power to another power, multiply the exponents. Let's try some examples. In our first exercise, we want to simplify the expression x to the fifth raised to the third power. We begin by writing that down, and we pay attention to the 2 exponents, 5 and 3. We multiply the 2 exponents together, and our result is 15. So the answer is x to the 15th power. It really is that simple. Here's one for you to try. Can you simplify this expression? Please pause the video here and come back when you're ready to check your answer. Let's see how you did. We have a power raised to a power, so we multiply the exponents. 6 times 7. 6 times 7 is 42, so our answer is x to the 42nd power. In our next exercise, we have x to the 7th times y to the 3rd, all raised to the 2nd power. We have 2 bases. First, we'll multiply the exponents for the x and the exponent on the outside, so 7 times 2. Then, we'll multiply the exponent on the y with the exponent on the outside, 3 times 2. Now we simplify. X to the 7 times 2 is x to the 14, y to the 3 times 2 is y to the 6th, and we're all done. Here's an exercise for you to try. Can you simplify this expression? Please pause the video here and come back when you're ready to check your answer. Let's see how you did. We have 2 bases, an x and a y. We'll begin by dealing with the x, which has an exponent of 5, and we'll multiply that 5 by the outside exponent of 3. Then we'll deal with the base of y that has an exponent of 8. We'll multiply the 8 by the 3 on the outside of the parenthesis, so we have 8 times 3. And now we simplify. X to the 5 times 3 is x to the 15, y to the 8 times 3 is y to the 24, and that's our answer. In our next exercise, we're going to introduce one additional piece, a coefficient, that sometimes is problematic. So let's talk about how to handle that. Here we have 4 x to the 5th, y to the 3rd, all raised to the 3rd power. That 3rd power on the outside of the parenthesis goes to everything on the inside. We have to remember that that 4 has an exponent of 1. So when we apply our rule, we'll have to use that 1 as the exponent of the 4. We'll begin by multiplying the exponent on the base of 4 with the outside exponent of 3, so 4 to the 1 times 3. Next, we'll deal with the x. X has an exponent of 5 times the exponent on the outside of 3, x to the 5 times 3. And finally, the base of y, that has an exponent of 3. 3 times the 3 on the outside gives us y to the 3 times 3. Now, we simplify the expression. We have 4 to the 3rd power, x to the 15th power, and y to the 9 power. We can do one last bit of simplifying by simplifying 4 to the 3rd. 4 times 4 times 4 is 64, x to the 15th, y to the 9th power, and we're all done. Here's one for you to try. Please pause the video here and come back when you're ready to check your answer. Let's see how you did. Once again, we have a coefficient on the inside of the parenthesis, so we'll add a 1 as the exponent. That exponent of 2 on the outside goes to everything on the inside. So we have 5 to the 1 times 2 power, x to the 7 times 2 power, and y to the 9 times 2 power. We now simplify. 5 to the 1 times 2 is 5 to the 2nd power, x to the 7 times 2 is x to the 14th power, and y to the 9 times 2 is y to the 18th power. We can simplify 5 to the 2nd power, which is 5 times 5, 25, x to the 14th, and y to the 18th. That's our final answer. Our next example is similar to those that we just saw, but a little bit different, and so we have to be cautious. Here we have 3 times x to the 10th to the 4th power. Notice that the 3 is on the outside of the parenthesis, not on the inside, and that the exponent of 4 is attached to the outside of the parenthesis, meaning that it only affects the things that are inside of that parenthesis, and therefore it doesn't have any impact on the 3 at all. When dealing with the x to the 10th, we'll multiply the exponents 10 and 4, so that we have 3x to the 40th power as our final answer. Here's one for you to try. Please pause the video here and come back when you're ready to check your answer. Let's see how you did. We have 8 times y to the 4th to the 9th power. The 8 is on the outside of the parenthesis, so the exponent does not affect it. We have y to the 4th to the 9th, so we multiply those exponents. 4 times 9 is 36, so our final answer is 8y to the 36th power. Next, let's take a look at an expression that has an exponent that's a binomial. Here we have x to the 4a minus 1 power, all raised to the 5th power. We use the same rule that we've used already. We have an inside exponent that goes with the base of x, 4a minus 1, and the outside exponent of 5. We're going to multiply those together. When multiplying the 4a minus 1 and the 5, remember you have to distribute. So we'll have x to the 20a minus 5. And that's the final answer. Here's one for you to try. Can you simplify this expression? Please pause the video here and come back when you're ready to check your answer. Let's see how you did. We have a base of x with an exponent of 3a plus 4. We also have an exponent on the outside of the parenthesis, the 7th power. To simplify this, we need to multiply the two exponents. So we'll have x to the 3a plus 4 times 7. We have to distribute the 7 into the parentheses, so we have x to the 21a minus 28. That's our final answer. This is everything you need to know to get started working with expressions that involve raising powers to powers. Be sure to check out our other videos on this topic in order to learn more about working with exponents. You can also learn more in Mr. Dorey's Algebra Handbook, available at www.doreypublications.com.